Hello everyone. Today we will discuss about the multiplexer. Multiplexer, as the name suggests, it has many inputs and single out. It acts like a rotating switch. Multiplexer is also called as the universal combination circuit. Here you can see block diagram of a multiplexer. Here are capital N input lines and there are small n select lines and there is a single output. So if capital N is number of the input lines, then we can write capital N as equal to 2 to the power small n, where small n is number of the select line. Now if we take the log of this equation, then we can write log n is equal to log 2 to the power n. Because in binary the base is 2, the base will be 2 for log of both the sides. So we can write here log 2 to the power n is as equal to n log 2 base 2 will be equal to 1. So it will be equal to small n. So we can write that the number of these select lines will be equal to log capital N base 2, where capital N is number of the input line. The multiplexer is also called as the data selector. Now here in this diagram you can see that it is a 2 by 1 multiplex. 2 by 1 means there are two input lines and there is one output. So these are the input lines and these are represented as D0 and D1. And if there are two input lines, then there will be one select line, because 2 can be written as 2 to the power 1. So it will be here a one select line that is represented by capital A. This is the diagram for 4 by 1 multiplexer. Here you can see that it has the four input lines D0, D1, D2, D3, and 4 can be written as 2 to the power 2. So there will be two select lines. So you can see here that A and B are the two select lines. This is also important to note that if there are two select lines, then there will be four rows. Or you can say that whatever the number of the input lines, then there will be similar number of the rows for the select lines. Similarly, you can see for 8 by 1 multiplexer, there are 8 input lines and 8 can be written as 2 to the power 3. So there will be 3 select lines. You can see here that A, B, C are the select lines. So here will be 8 rows for these 3 select lines. And you can see here one output. Now here you can see for 2 by 1 multiplexer that there are two input lines D0 and D1. Because there are two input lines, so there will be one select line. And this select line will have two rows because there are two input lines. And those will be 0 and 1. So we can find here the actual output as A is here 0 and 1, and the input lines are D0 and D1. Y is here not actual output. It is like an input. So here your actual output will be, we will write here the SOP form for the output. A is here 0, so it will be written as A bar and it will be written as D0 as it is. So A bar D0 plus 1 is here, so it will be written as A, and D1 is here, so it will be written as AD. So Y actual will be the SOP form of the table, and here for 2 by 1 multiplexer you can see that it is equal to A bar D0 plus AD1. Now here you can see that the logic gate expression of a 2 by 1 multiplexer, you can write Y actual as A bar D0 plus AD1, So you see here that there will be one AND gate, and here for this value there will be one NOT gate, and there will be one AND gate for AD1, and there will be one OR gate for this plus. So you can see that this is the one AND gate, this is other AND gate, and this is a NOT, this is an OR gate. So here you can see that your output will be A bar D0 plus A D1. So this is the logical gate expression of the 2 by 1 multiplexer. Now we will make the table for 4 by 1 multiplexer. Here you can see that there are 4 input lines D0, D1, D2, D3, and there is one output that is represented by Y. And because there are 4 input lines, so there will be 2 select lines. Those are called as A and B. If there are 4 input lines, then there will be for 2 select lines, there will be 4 rows. This to be important to note. So we will write here A, B as the input variables for 4 by 1 multiplexer. Those will be 0, 0, 0, 1, 1, 0, 1, 1. Now we will write Y as D0, D1, D2, D3. Here Y is not an output. The actual output will be SOP form of this table. So it will be A bar, B bar, D0 plus here you see A bar, B, D1 plus A, B bar, D2 plus AB, D3. So this is the output for the 4 by 1 multiplexer. Now similarly we can write the output for 8 by 1 multiplexer. Here you can see that there are 8 input lines, and so there will be 3 select lines, and these 3 select lines will have 8 rows, and those can be written as from the decimal number 0 to 7. So these will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So here we can make a truth table. So A, B, C are the input variables here, and Y as output, but it is not the actual output. So for actual output, we will write the SOP form, and it will be written as A bar, B bar, C bar, D0, then A bar, B bar, D, D1, then A bar, B, C bar, D2, then A bar, B, C, D3, then A, B bar, C bar, D4, then A, B bar, D, D5, then A, B, C bar, D6, then A, B, C, D7. So all these terms will be added. So here you can see that the actual output of the 8 by 1 multiplexer is of the form. Now here we will solve some numerical problems. There are 4 types of the problems in multiplexer. First type of the problem is that here we have given the 2 inputs, and they are converted into 4 input lines, and there are 2 select lines. Here you have to find the actual output. So we'll make a truth table. Here A, B are the select lines, and Y is the output. So for the actual output, we will write as A bar, B bar, D0 plus A bar, B, D1 plus A, B bar, D2 plus AB, D3. Now we will put the value of the D0, D1, D2 and D3 from the input lines. Here C bar, so it will be C bar and it will be C bar. So D0 is C bar and D1 is also C bar. So actual output in SOP form will be A bar B bar C bar plus A bar B C bar plus A B bar C plus A B C. If we solve this logical expression, then it comes out to be A bar C bar plus AC. Know that it is an output for the exclusive NOR gate. Can write it as. Now the second problem is that this is the diagram of a 4 by 1 multiplexer, and its one input is grounded. So when one input is grounded, it will be regarded as a 0. So here you'll see that this input line goes to D3, then there is a NOT gate. So if 0 is an input for this NOT gate, then there will be output 1. So this output goes to D1 and D2, and there is again a NOT gate. So this one will be converted into 0. So this corresponds to 0 input line. Now we will write the actual output for the 4 by 1 multiplexer, and it will be, because there are 4 input lines, so there will be 2 select lines, and there will be 4 rows for the 2 select lines. So we can write the actual output of the 4 by 1 multiplexer as A bar B bar D0 plus A bar B D1 plus A B bar D2 plus A B D3. Now we will put the value of D0, D1, D2 and D3. When we put the value of D0, D1, D2, D3, then we find that the actual output is equal to A bar B plus A B bar is equal to A exclusive for B. Now the third problem is that here multiplexer is given and it is of 2 by 1 order. There is also another multiplexer which is of 2 by 1. Because here we have the 2 input lines, so there will be one select line and it will have 2 rows. These will be 0 and 1. Let us say it is represented by D0 and this input line is represented as D1. So here your output F will be written as, in actual form, it will be A bar D0 plus A D1. We can write value of D0 and D1, so it will be A exclusive or B is equal to F. Now this F goes to the second multiplexer, which is of 2 by 1 order. Here you see that there are 2 input lines, so there will be one select line, and that is output of the first multiplexer. So it will be having 2 rows because there are 2 input lines. So this will be 0 and 1. So y actual here will be F bar. Here you see it is 0, so it will be F bar D0 plus there is 1, so it will be F into D1. Here D0 is 0, so this term will be 0, and D is here 1, so it will be 1. So we find that actual output here is A exclusive or B. Now the next problem is here that and that there is a multiplexer of 4 by 1 order and it has 4 input lines, so there will be 2 select lines. But here the one select line is added to an OR gate, so we have to find here the output. Now we can find the value of the F for 4 by 1 multiplexer, and it will be equal to, as you can see, A bar B plus A. So we can write it as A bar plus A and A plus B, or it is equal to A plus B. So F is here equal to A plus B, but we have to find here Y. So Y will be here because it is an OR gate. It will be A plus B plus B. So here, because B plus B is equal to B, so here your output will be A plus B. Now the next problem is here that there is 8 by 1 multiplexer and one select line is again going to the OR gate. It is having a NOT gate also. Here we have to find the value of the Y. Because it is 8 by 1 multiplexer, so there will be 3 select lines and these are the input lines. So if we find the value of the F, then it can be written as in actual SOP form as it will be like this. Here you see A bar, B bar, C bar, D0. Because for SOP form it will be written as A bar, B bar, C bar, and it is your D0. So A bar, B bar, C bar, D0. Similarly, we can write the other values. So if we solve, we find that your F is here comes out to be A bar BC plus A B bar C plus A B C bar plus A B C. Now here C goes to this NOT gate. So it will be here written as C bar and then there is a OR gate. So our actual output will be A bar BC plus A B bar C plus A B C bar plus A B C. This term is for F and C bar is written for this input line. For this OR gate, so it will be plus C bar. Now when we solve this, we find out that our actual output comes out to be BC plus CA plus C bar. Now there are type 2 problems. In these types of the problems, we have to implement a higher order multiplexer by using lower order multiplexer. So here you can see that we have to implement a 4 by 1 multiplexer by using 2 by 1 multiplexer. So here you can see that it is a 2 by 1 multiplexer. This is a 2 by 1 multiplexer. This is the select line, so it will be common to for these two multiplexers which are of 2 by 1 order, and then it is the other line. So here you can see that we will require 3 2 by 1 multiplexer for making multiplexer of 4 by 1. How we can find this number? Now see, if we have to make here 4 by 1 multiplexer by 2 by 1 multiplexer, then we will divide this 4 by this number and we will divide until we get the output 1. So first we will divide 4 by 2, so we will get 2 is 4. So here we are getting 2. So we will write this 2 as here, then we will divide this 2 by again 2, then we get 1. Now when we get output 1, then we stop. So the total number of the multiplexer here will be 2 plus 1, that is equal to 3. Similarly, here you can see that if there is 8 by 1 multiplexer and we have to construct this 8 by 1 multiplexer by using 2 by 1 multiplexer. Now see here how it happens. First we will divide 8 by 2, it comes out to be 4. Then we will divide 4 by 2, then it comes out to be 2. Then again we will divide this 2 by 2. Our output is now 1. So we will stop here. So our total number of the multiplexer are 4 plus 2 plus 1 and it is equal to 7. So we can write in general if there are 2 to the power n into 1 multiplexer is used, then it will require 2 to the power n minus 1 multiplexer. Now if there is a 16 by and we have to construct it by 4 by 1 multiplexer, then we will divide this 16 by 4, so it comes out to be 4 4 is 16. Now again we will divide this 4 by 4, it comes out to be 1. When it comes 1, then we stop. So here we will require 4 plus 1, 5 multiplexer of 4 by 1 order, construct a 16 by 1 multiplexer. Similarly, here you can see that for 256 by 1, let's say 1660 is a 56. Then again we will divide 16 by 16, it comes out 1, plus 16 plus 1 will require 17. Similarly, for the other, we can see that how many number of the multiplexers will be required. Now the third type of the problem is that we have to implement the logic gates by using multiplexer. First we will use by using a 2 by 1 multiplexer. Now this is the NOT gate, so that when your input for the NOT gate is A, then output will be A bar. So we will use 2 by 1 multiplexer to get this output A bar. So here we will use two input lines. There will be one select line, it will be 0 1, and here our inputs will be 1 0. If you find here the actual output, then it comes out to be A bar 0 plus A D1. So A bar D0 is here 1. So it will be written as A bar into 1 plus A, and D1 is here 0, so it will be Y will be here A bar. So when your inputs are 1 0, then we will have an output equal to a NOT gate from a 2 by 1 multiplex. Next is AND. Here you'll see that this is the AND gate. It has the two inputs. So here your output will be AB. Now this is 2 by 1 multiplexer. So there are two input lines, and here we have to select the input lines 0 and B. Our select line will be 0 1 always, because we have here two input lines, so there will be one select line and there will be two rows. Those will be 0 and 1. So here your actual output here will be A bar. For SOP form, it will be written as A bar D0 plus A D1. So here your Y will be A bar. Here D0 is 0 0. It will be 0 A, and D1 is here B. So your output is AB. So for AND gate, we will use a 2 by 1. It will have the input lines 0 and B. Here it is 1 0, then 0 B. It is not, it is AND. Then next is exclusive OR gate. So that if A, B are the inputs of the exclusive OR gate, then our output will be A bar B plus AB bar. So for 2 by 1 multiplexer, we will have the inputs B and E bar. Now see here, your first input was 1 0, then 0 B, then B bar. So here if you write the actual output by using the SOP form, then it comes out to be A exclusive or B. Then for exclusive NOR gate, here your input lines are B and B bar. For exclusive NOR gate, this will be reversed. So here we will write B bar and here we will use B. So you can see that if our input lines are B bar and B, then our output will be equivalent to the exclusive NOR gate. Then for a NOR gate, you see here your output will be equal to A bar dot B bar. So if we use the input lines B bar and 0, then our actual output for 2 by 1 multiplexer will be A bar B bar. Then for OR gate, you know that output will be A plus B. Here A and B are the inputs. So for the 2 by 1 multiplexer, we will select our input lines as B and, then we select our input lines B and 1. we see that our output is of the form A plus. Then for the NAND gate, see that for the NAND gate, your output is A bar plus B bar. So when we use 2 by 1 multiplexer, then our input lines will be 1 and B bar. So we can find here an output that is equivalent to a NAND gate is equal to A bar plus B bar.